Okay, everybody, last but not least, we have equations with special cases. So when I say special cases, I mean typically what we've been solving so far, all of our equations have had one solution. Well, that's not always the case. So our first special case is in fact one solution, and that's what we've been solving. X is 5, x is 7, x is 10, x is something. So in this type of equation, only one number will work to make the equation true. So for example, if we have the equation 3x minus 7 equals 5, well, what does x have to be that when I multiply it by 3 and then subtract 7, I get 5? So we would solve this, and the first thing we would do is add 7. 7's cancel. 3x equals 12. And then divide by 3. So x equals 4. So the only solution that's going to work is when I take 4 and I substitute it back in. I would have 3 times 4 minus 7 equals 5. Well, 3 times 4 is 12, minus 7 equals 5. Yes. If you try to substitute anything else, if I tried to substitute 5, 6, 7, 8, 9, it wouldn't work. So there's only one solution. Next special case, zero solutions. In this type of equation, there is no number that will make the equation true. So, for example, 3x minus 4 equals 9 plus 3x. Well, in this case, I have variables on both sides of the equation. So I would distribute first, can't do it. Combine like terms, can't do it. So I'm going to try to get all the variables on one side and all the numbers on the other. So if I try to get all the variables on one side, I'm going to subtract 3x. Well, on the left, 3x minus 3x is 0. They cancel each other, and I just bring down my negative 4. Equals. On the right side, well, 3x minus 3x is 0. They cancel each other, so I just bring down my 9. Now I'm left with the equation of negative 4 equals 9. Well, that's not true. So, no. Meaning, no solution. So think about this. If you plugged a number in for x, let's say I plugged in a 1, I would be looking at 3 times 1 minus 4 equals 9 plus 3 times 1. Well, 3 times 1 is 3 minus 4 equals 9 plus 3 times 1 is 3. Well, 3 minus 4 is negative 1 equals 9 plus 3, which is 12. No, that's not true. So you can keep doing this and trying this, but when you get down to a statement that is not true, such as negative 4 equals 9, what that is telling you is that there's no solution to that equation that will make it true. Our last special case is all real numbers, which means infinitely many solutions. In this type of equation, all numbers will work to make the equation true. So let's take a look at what this looks like. Distribute first. So 4 times 6x is 24x. 4 times negative 4 is negative 16. Equals 8 times 3x is 24x. 8 times negative 2 is negative 16. Now, first of all, if you're looking at that, do you notice that the left side of the equation looks exactly like the right side of the equation? So if I plug the same thing in on the left and the same thing in on the right, no matter what it is, I should get a true equation. So right there, you could almost stop and say, okay, this is true all the time. But if I keep going, I would subtract 24x. Those are going to cancel. and I'm going to bring down my negative 16. Those are going to cancel. I'm going to bring down my negative 16. Now, in this case, all of your x's are gone, and you have a true statement. You have negative 16 equals negative 16, which means all real solutions. Okay, you can put any number into this equation, and it will work. So if you get a true statement, all real solutions, and if I back up here, if you get a false statement, no real solutions. Examples. Solve each equation and tell how many solutions or solution it has. So, on this one, we can't distribute, we can't combine like terms, so I'm just going to try to get all the x's on the left and all the numbers on the right. I'm going to start, and I'm going to subtract 5x from both sides. 5x minus 5x is 0, so I'm just going to bring down my negative 7. 5x minus 5x is 0, so I'm just going to bring down my 9. Now I'm looking at that. Negative 7 equals 9. Is that true? And the answer is no, that's never true. So this says no solutions. Next one, 9x minus 17 equals negative 17 plus 9x. So on this one, I can't distribute, I can't combine like terms, so I'm going to try to get all my variables on one side. 9x minus 9x is 0. I'm going to bring down my negative 17. 9x minus 9x is 0. I'm going to bring down my negative 17. Okay, all my variables are gone, so once again I'm going to look at that. Does negative 17 equal negative 17? And the answer is yes, all the time. Negative 17 is always equal to negative 17, so all solutions. The answer could be 1, the answer could be 2, the answer could be 3.5, the answer could be negative 10, the answer could be anything you want it to be. Last but not least, 7x equals 5x minus 25 plus 30. So, distribute? No. Combine like terms? Yes. If you take a look at the right side of your equation, you have a negative 25 and a positive 30. So I'm going to combine those. Negative 25 plus 30 is 5. Then I'm going to bring down my 5x, and I have a plus 5 because it was positive. And then over here, drop down your 7x. Then I'm going to try to get all my variables to one side of the equation. So I'm going to subtract 5x. 7x minus 5x is 2x equals 5x minus 5x is 0. And then I'm going to bring down my 5. I still have an x, so I have to get it by itself. So I'm going to divide by 2. X equals 2.5. So this has one solution. And the one solution that's going to work is only 2.5.